Yo, what's up, gang? I'm back post Thanksgiving, had all my turkey, and we're here with another LeetCode. In today's question, we're going to be solving count good nodes in binary tree. So, let's dive right in. Seems like given a binary tree, a node in the tree is good if the path from the root to that node has no nodes with a greater value than that node. That's a little confusing, so let's look through these examples. It's saying nodes in blue are good. Yeah, because if you go up here, you can see if you're at this 3, the 1 and the 3 are both less than or equal to the 3. And the 1 has this 3 here, so it's not a good node. Whereas this 4 greater than 3, 5 greater than 4 greater than the 3, so these are all good. But the 1 has the 4 and the 3 that are greater than it before. I guess here's another one. It's a less even tree, but still here this 4 is good because it goes up. The 3 is good, but the 2 is not good because if you travel back up the tree, you have some numbers that are greater than it. Alright, so let me write out a tree here, and let's see if we can find like an approach. So I'll just use their example. That's got to be a good one. 3 goes to 1, goes to 3, goes to 4, goes to 5, goes to 1. So immediately, since this is a problem about like going from root to any node like deep inside of a tree, I'm thinking of going with a depth first search. I guess when approaching tree problems, especially traversal problems, there aren't that many options. I mean, the main two options really are just depth first search or breadth first search, and a lot of the times both of them work, but it's simpler to do the depth first search because you can do that recursively using the stack instead of having to set up that boilerplate for the breadth first search. Sorry, a lot of hard words. Let me take a look at this tree. So we would start up here at the root, obviously, and then we go down here, and I want to perform some sort of check. I think what we need to do this in one breadth first search is perform a check at each node and then like do some sort of operation on that node. So here, this 1 is not good, right? Because you check if the value at the node, so 1, and you want to make sure it's strictly less than the maximum value that came before it, and in this case that's 3. So this is no good. And I'm trying to decide when to do this, but ideally, and I think here we actually replace this with a 3. So then we can go down here. Or actually, no. I remember I was looking at this problem earlier and I ran into this issue where I was trying to like replace nodes in the graph, but you don't actually have to replace them. You just need to keep a max value like at that, like at each branch like location. Because max value here is 3, max value here is 3, and max value here is also 3. So then, at each node, you just check is current value less than max value. Or even you could do it the other way around. You can just check if it's greater than or equal to max value, and then, in that case, update max value. Let me draw this out cleanly, because this makes sense in my head, but I don't think I explained this too good. I'm still getting used to like how to use this pen and how to go about explaining LeetCode questions. I want to do this until I actually get a job, and in theory, I would get better at this as I keep doing it. So I'm going to use max value for like MV for max value and CV for current value. So these are both 3. Or actually, we can just simplify this even more. Just M is 3, C is 3. At each level, we want to check if C is greater than equal to M, so the new current value is greater than the previous max value. We want to set the max value to that current value, and we want to count. So this is good. Good node. Nice. So we can go down here, and that check would fail. It would pass. It would pass. The max value here would be 4, so then 1 is not greater than 4, so this would fail. And here, this one would pass. Because here, max would be 3, max is then 4, max is then 5. But at this level, the max would stay at 4. You know, we would have to differentiate, like, this is different than that. But that makes sense. Let's just get into the code here real quick. So I'm gonna need a boilerplate DFS for sure from a node, since it's gonna be recursive. And to do that on a binary tree, so I just have to check if current left, then just run the same thing on current left, and if current right, also run the same thing on current right. But we want to keep a max value at each level, so we actually want to add that to the function, like the argument here. And then oh man, I just have to do something. I have to do that check I wrote out. So if current.val is greater than or equal to the max val we have stored, then we can just update the max val and set a count. So we need like a global count, because we don't want to count at each branch. We want like here, part of the actual thing. So we can do, I don't know if I need the self here or not actually, but I'm sure we'll figure it out. So boom, max val in here as well, and there as well. And then I'm not actually doing anything yet, so I have to call this at the root, and the max val at the root is the root val, and then I want to return this self.count. Okay, this makes sense in my head. We set up a DFS boilerplate, which is just this and the function argument, and then we do this check at each level, and we keep track of a count, and then we return the count. So let's see if this works. Nice. Yeah, I think you do need the self.count. If I just did count here, let me see if this would work actually. I don't think it would work because it would be local. Yeah. Can't access local variable count. I think another thing you could do is you could do like non-local count. There's like some weird, like if you weren't inside of a class, this is I think how you would do it. Well, if you weren't inside of a class, you would just set it like outside. Yeah, this also works. But if you're like not in like a LeetCode environment, I think you can, I think this would also work. I don't know, this is all Python stuff, doesn't matter too much. Oh no, this also doesn't work. You would need the non-local. It's the same issue. I'll do it here with the non-local. Whatever. I don't need to put all the self-spec, but nice. This should submit. Cool. Pretty fast, but that doesn't matter. The complexity is right, and that's the only thing that actually matters. Okay. Awesome. Until next time. Bye.